You are watching The Morning Show, WCIA 3650. Here's what's in the news this morning. 240,000 Americans started voting to have a say in their country's new constitution. Decatur teachers get their raise and cut 15 minutes out of the workday. The deal has been approved by the board. And State Representative Bob Fleiter has a competitor. Restaurant owner Dick Kane will try to unseat him. More on those stories at 7.
The brunt of the winter weather today, but we still need to remember how to drive out there in the slushy conditions, and physics professor Matt Selman is here today.
It took me twice as long to get up here today as it normally does. I was going 30 the whole way, and everybody else was, which is a good idea. When it's slippery like this, people have the idea that you're supposed to go slow. At least most people do. One guy passed me going really way too fast, and he almost went in the ditch. And I thought,
dovetailed?
Yeah, so that's no good. So you got to be a little careful. So
how does that work when someone dovetails? Can you explain like the friction and traction behind all this?
So we're going to start right at the very beginning, because Newton's first law says everything you have to know about driving in the snow.
Okay.
Do you remember what that one is?
No, I don't. It's been a long time.
Okay, it says basically one thing. It says that whatever something's doing, it wants to keep doing exactly that. So if something's at rest, it wants to stay at rest.
If it's in motion,
if something's in motion, it wants to stay in motion. But what that means is it wants to keep going in one direction with one speed.
Oh, okay.
So the velocity doesn't change. So it's fine if you're just sitting at rest and it's really slippery. You know it's hard to get going because the wheels will spin and it takes a while to get started after you stop at a stoplight, right? If you're going in a straight line, and then if you want to make a corner or you want to slow down to stop at a stoplight, anything like that, that's when you get into trouble. So that's when forces come into play. Whenever the car is going to change its velocity, that means it's going to have an acceleration. That means you need a force, and that's what Newton was all about. And so it's the thing we need to understand is what kind of acceleration, what sort of forces do you need when you're driving. Okay, so there's starting and stopping. That's kind of easy. That means if you're at a stoplight and it turns green, you may fishtail and you may start going a little bit. And we'll talk about friction and fishtailing when we come back. Okay. But anyways, the thing that gets people the most is turning corners. Because that's usually where people wipe off and go off the road is when you're trying to turn. And to understand that, I need you to spin. Hold that on. Hold on to that thing. Now spin it around over your head. Okay. Now, what does it feel like, that string? Does that string tense the whole time you're spinning it? Right. It is tense because when something is moving in a circle, you need a force always pointing inward to keep it going in a circle. That's because it wants to keep going straight. If I just let go of this ball,
it's going to hit Robert, who's standing off to the side.
If I go like this and I let go of it, it keeps going in a straight line like that. Just like this little car, which is right here. It wants to go in a straight line. I turn the wheels, and the whole time, in order to keep this thing going in a circle, it always has to be bent, and the force always has to be inward. Now, if you're in a car, the force that makes you change what you're doing, that causes you to accelerate, is the friction between the wheels and the road. That's all you have, right? And so if you lose that frictional force, then the car is going to do whatever physics tells it to do, which is to go exactly in a straight line at the same speed it was always, which means that you go right through that intersection, or you'll go right off the corner and go in the ditch and all that good stuff. And so what we really need to do is to understand friction. Now,
which very quickly.
Sorry. Well, what we'll do actually, since one thing that's very important is the friction between the wheels and the road, and one manifestation of that in modern technology actually is that people can design anti-lock brake systems for cars, which use our knowledge of scientific knowledge of friction. So maybe when we get back, we'll talk about anti-lock brakes, and we can explain all this stuff a little bit.
We will do that in 30 minutes with the Wise Guy. It is coming up here on just past 6.